quadrant 3, if you use all-star trig class, and here I am, the ordered pair is negative, negative, which means cosine and sine are negative, but tangent has to be positive. Tangent and its inverse is positive. So check this out. The sign of tangent in the third quadrant is what? What is it? Positive. The SIGN sign of sine in the third quadrant is what? Clearly it's negative. And then the cotangent in the third quadrant, well, folks, cotangent is what's inverse? Tangents. So if tangent's positive, cotangent is also positive. What's a positive times a negative? A negative. What's a negative divided by a positive? Negative. Okay? Makes sense? All right. What was the, did somebody say 46? 46, 46, cosine, secant. Cosine and secant. Cosine, secant. Did it say, oh, and it said any quadrant, didn't it? Okay. Here's the thing. Again, all-star trig class. The first thing I locked into when I looked at this is that cosine and secant are inverses of each other. And that kind of made my ears go, whoop, just kind of like, something's going to happen, especially if it said any quadrant. But let's see what it happens in the first quadrant. All right, we got to find the sign of the product of cosine times secant. What is cosine's sign in the first quadrant? Positive. How about secant? Positive. Positive times a positive is a positive. Let's look at quadrant 2. The only ones that are positive are what in the second quadrant? Sine and cosecant, which means cosine and secant are both negative in the second quadrant. What's a negative times a negative? Positive. I guarantee you that's where you made your mistake, okay? Quadrant 3, tangent is the only one, tangent and cotangent are the only ones that are positive. Therefore, cosine and secant are negative. Hello, what's a negative times a negative? Positive. And then quadrant 4, hey, we're finally in the C quadrant, which means cosine and secant are both positive in the fourth quadrant. What's a positive times positive? Positive. Bless you. In any quadrant, folks, the product of these inverses are what? Is what? The product is positive in any quadrant. The answer would be positive. Kind of a tricky question. Just making sure you know what's going on, okay? Know where you made your mistake. Yeah. And I bet you did here too, quadrant 3. You did? Okay. Was that the only one you got wrong? Second and fourth. Okay. All right. Questions at all? Everybody good with this? Folks, this is not meant to like bend your brain in half. It's only meant to kind of make you tough. This is like your 15 reps of light weights just to make you, I don't know. I just made that up. I don't know anything about lifting. But it's fun that I can kind of sort of act like I do. Did we say 47? Did anybody have a question on 47? 48. Okay. I knew it was one of those. All right. So let's look at 48. 48 was tangent and sine, correct? Tangent's positive. And sine is negative. Is that what it said? Which quadrant? All right, look at this. This is my logic box. And some of you came back to my desk yesterday and I was able to tell you this like one-on-one. But for whatever reason, I didn't tell you this as a class. This is my logic box that I talked about yesterday. This is when I do some eliminating. Tangent is positive. We're the only two quadrants up there where tangent is positive. The first one and the third one. So I've got to mark everything else out. because nothing else matters. Now, that one's taken care of. Now, out of what's left over, I've got to figure out where sine is negative. There's only one up there where it's negative. What is it? Quadrant 3. Why did I choose that one? What do we know about the first quadrant, folks? Everything's positive. So my answer is quadrant 3. Okay? Does that help on that one? I like those problems. Folks, you're not going to have maybe one on a test like this, because this is not the important stuff. It helps us, but it's not the important stuff. Okay? Questions at all? All right, moving on. Here we go. Notes. Let's roll. Okay, we're still finding all the 6 trig functions, but we're going to be given some information a little bit different than normal. First example, where you're told that the sine of the angle, sine of t, is equal to 5 over 13. We're given that. And we're given that cosine of t is less than 0. That's all we're given. Now, I told you last week that there are times, I said this will all make sense next week. Give me a week, and it's all going to come together. There really is a method to my madness, okay? There really is a reason that I cover things in the order that I do, because eventually you're going to go, oh, that's why you did that then. I got it now. And it will be clear to you, okay? Not only is it clear to me, that's the most important, but it has to be clear to you. Now, what's this telling me? What do I have to know? If I can find all 6 trig functions, right? I can find sine and its inverse, and I can find cosine and its inverse, and I can find tangent and its inverse. But folks, this information that we're given gives us certain information. Look at the information you're given. Now, I'm going to just tell you right now, the first example we do is going to have the most work. It's going to have the most notes in this one example, because when you're at home working on the homework, studying, because I know you guys work on this every night, you ought to be able to go through this first example step by step by step and follow and do any of these types of problems, okay? So it's going to be a lot of notes in this first example, and it's going to take us a while to do the first example. But after this, you ought to be good to go, all right? First thing you need to do, look at the information given. Look at what you're given. As a whole, look at what you're given. By doing this, it helps determine the quadrant. That we're working. It helps determine the quadrant in which we're working. Okay? How is that going to help determine the quadrant that I'm working? Why is that? Why do I even need to know that? What do you notice? What do you notice about the sine value? In general, what do you notice about the sine value? It's positive. The sine value is positive. The sine value is positive. I'm not even really concerned about the value of it yet, but I am concerned about generally the sine. What is the sine of the cosine value? Negative. How do you know that? Because it tells you it's less than 0. Hey, if your ordered pair is negative, positive, which quadrant are we working in? Think. Up here, right? It's in the second quadrant. Because of this right here. Yes. The cosine of t is less than 0, whoever asked that. If it's less than 0, cosine has to be negative. Okay? Now, do I need to worry about any of the other quadrants? No. All I'm concerned about is quadrant 2. So, folks, I'm going to draw my coordinate grid, but I'm going to draw it so that it's heavy in quadrant 2. Question? Because my sign value was positive 5/13. No, because your ordered pair is cosine sine. Right? Okay, brain fart. It's all right. My quadrant is quadrant 2, so I want to draw my grid heavy on the quadrant 2 side. So it's going to look like this. That's really all I need to see, because look, here's quadrant 1 over here. Here's quadrant 2, which we're going to be working in. Quadrant 3, quadrant 4. I only need quadrant 2. Now, remember last week when we went over some old horse caught a horse taking oats away? And y'all were like, why are we doing geometry? This is why we were doing geometry, okay? I want to draw my angle T in the second quadrant. And I'm going to draw it anywhere in there, but make it kind of nice and big. There it is. Drop an altitude like always. And your angle T is that angle in the right triangle that is closest to the origin. Okay? All right, so I got a right triangle. Do I have any information given to me that will be beneficial to this particular right triangle? My base is 1. Why would the hypotenuse be 1? Okay? Because of the radius of the unit circle. All right, but hold on. What else am I given? What kind of information am I given for this angle T? Oh, because there's a reason we did that last week. When I had to circle that angle, my angle was T, and I had to label my triangle. Remember doing that last week? We did it in geometry. We did it last week. Folks, look at this. Are we given sine of T is 5/13? Okay, that means that with respect to angle T, if sine is 5/13, that means I'm dealing with some old horse, does it not? All right, so that means with respect to angle T, the opposite side is what? Number? 5, bless you. And my hypotenuse is what number? Bless you. 13. Y'all with me? Yep. All right, look at what we're given. Okay? Did you understand why we're in quadrant 2? Okay? You understand that I have to draw my angle, my T. I have to drop my altitude. It's creating my right triangle, correct? Now, step back from it and look at what you're given. The only thing I know is that my sine of angle T is the ratio 5/13. All right, so go into your right triangle file folder, and you flip through, and then you know from way back that the sine of any angle is the opposite over the hypotenuse, correct? It's some old horse, so that means 5 is your opposite, hypotenuse is your 13. You with me? Now, look at that. What am I missing? Oh, I'm missing my third side. All right, so let's look at this. The first thing we did is we had to figure which quadrant we're supposed to be in. That was the first thing we did. Second thing we have to do is we've got to find the third side. Okay? We've got to find the third side. Because I've labeled everything that I have at this point. I've used all of my given information. Now I've got to find my third side. Folks, in a right triangle, how do you find the third side? Oh, we have to use Pythagorean theorem. Sometimes, got 2 little bullet points we're going to put under here. Look at those values, 5 and 13. Do those values look familiar to anybody? 5 and 13. 5, boom, 13. What? No. All right, write this down. When we're doing these problems, you're going to run across sets of numbers called Pythagorean triples. Do y'all remember that? Does that sound odd? I just saw the light bulb for some of you. Pythagorean triples. There are two common triples that we come into contact with a lot, okay? The first one, well, let me tell you what they are. Pythagorean triples just automatically work. They automatically, those numbers work and form right triangles, okay? Those numbers or any multiple of those numbers. The first one, the most common one, bless you, is the triple 3, 4, 5. Okay? That's the first one. And I would write this down because you're going to see these triples come up again. Or any multiple. Now, what do I mean by multiple? You may have a triangle with the sides. Check this out and watch. The sides might be 6, 8, and 10. They might be 9, 12, and 15. So you may see these specific numbers, 3, 4, 5, or any multiple of those. The other triple, do you know it, Kelly? No. 5, 12, 13. If you didn't know, folks, what is the numbers that I've given you? It's the triple, okay? So my third side is going to be 12. Now, I'm going to put it in blue, okay? If I didn't know that, and let's face it, some of us are going to work, and I would be one, that I would be working doing the same thing, and I would go, I'd totally miss it. Because I'm a tree person. I'm into the details. If I didn't see that that was a triple, Quentin, you said it 5 minutes ago, what am I going to have to use to find the third side? The Pythagorean equation, okay? And I would just put this. If you're given a weird ratio, and when I say weird, like if you're given the numbers 17 and root 5, you got to know you're going to have to use the Pythagorean equation. If you're given these wild out there numbers. Then use the Pythagorean equation. And I will stick to my Pythagorean equation version every single time. You can use your ABC thing. I'm going to use my hypotenuse squared is equal to legs squared plus legs squared. Because it's a no-brainer for me. I don't have to figure anything. I know what the hypotenuse is. I know how to find the legs, okay? So if I didn't see that if I didn't realize that 5 and 12 or 5 and 13, that third side was 12, then I would go straight to Pythagorean equation and I would solve and I would figure out that, hey, I'm missing side 12. And think about it, y'all. Pythagorean equation, think. If my hypotenuse is 13, what is 13 squared? 169. What is 12 squared? 144. What's 144 plus 25? That's 169. So, see, my numbers have to match. The sum of my legs squared have to match my hypotenuse squared. That's just going back to your Pythagorean equation, okay? Now, I know my third side. Now what? No, you're sometimes going to have, we didn't find the hypotenuse this time. We found the leg. Sometimes you may have to find the hypotenuse. Same equation. Yeah, same equation. But it may be just a different number in a different place in that equation. And then you just solve that equation algebraically. Okay? Good question. I got my third side. What the crap? What was all of this? I got to find the 6 trig function. Trig functions, y'all. We're going to find the trig functions. Here we go. Third, let's find them. Find all 6 trig functions. Because we have our three sides now. There are two of these ratios you better not get wrong. If you get them wrong, you ought to kick your own self in the tail. There's one you're definitely not going to get wrong. What's it going to be? You better not get sine wrong. It's given to you, folks. Sine of t was what? 5/13. That means its inverse is what? 13/5. Cosine. Go to your right triangle. This is why we did this. Some old horse caught a horse. 5/13. What is it? 12/13. Whew. All I'm doing is using some old horse caught a horse, adjacent over hypotenuse. Adjacent over hypotenuse. What's your inverse? 13/12. So secant is 13/12. Tangent. Some old horse caught a horse, taking oats away. Opposite over who? So it's what over what? Opposite 5/12. What is cotangent? 12/5. Now, are you cool with just getting those numbers from the right triangle? Hey, are we doing trig? How much trig are we doing and how much geometry are we doing? Probably about 25% trig and 75% geometry. Okay? Do you see how it all goes together? Now, what quadrant are we in? I'm in quadrant 2. Say it again. This is what we have to do. Third, we found our trig ratios, and we used some old horse caught a horse, taking oats away. The fourth thing we need to do, and I keep saying it and saying it, you need to be mindful of your signs, your SIGN signs. And folks, I don't ever put my positive and negative numbers in until the very end. My positive and negative signs, okay? We're in Q2, right? So that means, all right, so I'm over here. That means negative, positive, cosine's negative, sine is positive. What's tangent? It has to be negative. So I'm going to go back and I'm going to use that little helpful tool, whatever you want to call it. And I'm going to go, okay. Well, I'm going to go back up in here and I'm going to fix my ratios. Cosine has to be negative. So cosine and its inverse are negative. Tangent has to be negative as well. Tangent and its inverse are negative. Is my sine, are my sine values positive? Yes. Am I done now? Now I'm done. Okay? Will every problem take you this long? No. Absolutely no. No way, no how will it take you this long. You know what the most difficult part's going to be for some of you? Sometimes? What do you think the most difficult part of this is going to be? Pythagorean equation. Because what happens when it's not a 3, 4, 5 or a 5, 12, 13? Holy crap, it's going to be crunching numbers, Pythagorean equation, and what if I got to rationalize? Oh my God, it's going to take even longer, right? How about pulling the numbers off the triangle? Is that facile or difficile? That ought to be the easy part. There are two up there you should get right no matter what. In this particular problem, you should get, even if you get everything else wrong, you ought to get two of them right. Which two should you get right? Sine and its inverse, because that was what was given to you, right? You better get them right. If you don't, I'm going to write ugly notes on your paper. Now, here's the thing. when you're at home doing this, and you will be at home doing this at some point, this example should be able to take you step by step by step by step, okay? Go back and look just to refresh, review. First thing you need to do is you need to look at what you're given, which helps you determine which quadrant we're working in, okay? Once you figure that out, then you got to find the third side of that triangle. Please pay attention. I'm just not up here for my health. If that were it, I'd be at home on my big old hind end, or my feet kicked up, okay? Third, find all your trig functions. Find the functions and their inverses. Last thing you got to do, you got to go back and check your signs. Be sure you get your signs. If you don't get your signs right, it's wrong, and that would suck. Okay? Let's look at another one. Here's another one. If secant of t is 2 and sine of t is less than 1, find all 6 trig functions. And I would just go on and start making sine of t, cosecant of t, cosine of t, secant of t, tangent of t, cotangent of t, before I did anything, before I even draw a picture or anything. What do you know? What do you know? What are you going to get right? If you don't get anything else right, what are you going to get right? You're going to get secant right, which is 2. Or actually, it's what? It's actually 2 over 1, isn't it? Will that help me? How will that help me? I can go ahead and figure out cosine, which is what? Oh, okay. That might help. What else do I need to do now? Oh, I got to find the quadrant. How am I going to do that, Jansen? Sines. Okay. So secant is what? Positive. Were you thinking about secant, or are we really thinking about cosine? So cosine is positive. Sine is negative. Our ordered pair is positive, negative. Which quadrant? Here we go. Y'all see me figuring it out? It's down here. Which quadrant's down here? 4th quadrant. So I'm going to make my coordinate grid heavy on the 4th quadrant. Right? There it is. I do this not to take up so much space. I could draw the whole thing. Now what? Draw my angle. Draw my angle. There it is. What now, Zach? Drop that altitude. There it is. There's my right angle. Remember that your angle T is that angle inside the triangle closest to the origin. And it could be a theta, a T, or alpha. It could be anything. Could be called anything. Now what? Somebody else. What do I do? What do I do now? I know that my cosine is 1/2. Will that help me? How? How do you know? Sum of horse caught, a horse adjacent over hypotenuse, right? And the adjacent is, you said, along the x-axis. You're right, that's 1. I'm going to make that red. And the hypotenuse, of course, is the diagonal, which is 2. What you thinking? No. Secant is the reciprocal of cosine. Well, if you do, though, remember this is secant, and we've got to get to the reciprocal because caught a horse is cosine. Okay? So it's got to be caught adjacent over hypotenuse. It has to go with cosine, not with the reciprocal of that. Okay? What now? Anybody recognizing any numbers? Pardon me, I'm distracted. Go ahead, Jansen, ask it again. No. I was distracted. Folks, Jansen, ask your question. Oh, yeah, what is it? It is a special right triangle. Can't be a 45, 45, 90 because think of those numbers. It's a 30, 60, 90 triangle. Your short leg is 1. Your hypotenuse is 2. What's the third side? √3. And if you don't know it, which most of us obviously are looking at it going, what? How am I going to figure it out? How am I going to figure out the third side? Say it. Pythagorean equation. Here we go. Come on now. Blow that cell phone up. Here we go. Here we go. What's the hypotenuse? What? Folks, let me tell you something. So, what's the hypotenuse? It's 2 squared. I'm going to go there first. What's the leg? 1 squared. Right? Now, 4 is equal to 1 plus leg squared. Subtract 1 from both sides. This is how I'm going to get. When I subtract 1 from both sides, 4 minus 1 is 3. And now I'm going to take the square root of both sides, and it gives me, like he said, √3, right? Okay? √3. So my √3 is there. I found my missing side. Now do you have enough information in your triangle to find the sine, the cosine, the tangent, and their reciprocals? Yes, do it. And go back at the end and check your SIGN signs to make sure that everything's like it should be, okay? Remember, because we ended up in the 4th quadrant. See what you can do with that. All right, so what'd you get for sine? Some old horse. √3/2. Cosecant then is going to be the reciprocal. And when you rationalize it, did you get 2√3 plain old 3? Okay, oh, this is spooky. I'm trying to do this in my head. Tangent, some old horse caught a horse taking oats away. √3/1, which would simplify to just plain old √3, correct? And then when you flip that over and rationalize, don't you get √3/3? Yes. If you don't, oh no, no, if you do this, that's totally fine because I have to see it to know I got to flip it. No, I would not. It is correct. Now, what do we have to be sure we do? Now we have to worry about the SIGN signs. We're in the 4th quadrant, which means positive, negative, negative. You guys agree with that? So, sine has to be negative, and its inverse has to be negative. Tangent has to be negative, and its inverse has to be negative. Bless you. Cosine, and this one is the only one that's positive, correct? How many of you got every bit of this correct? High five in the air. Good. Excellent, excellent, excellent. Let's go with another one. Questions at all? Folks, the problem here is if you can't do the right triangle. If you don't know or understand some old horse caught a horse, then you're going to be up the creek. Let's look at the unit circle. Now, I tell you what, I want you to do this one. This one, I'm going to just tell you right now, it's going to be a beast because of the rationalizing. So get ready. Here we go. I want you to do this one completely on your own. I'm going to give you that cosecant of t is 5 and cosine of t is greater than 0. I want you to find all 6 trig functions Make sure everything is correct. I'm going to give you I'll give you 5 minutes. All right. Here we go. Fun times. How many of you finished it? You got to kind of hoof it to get that problem finished. It was some ugly rationalizing, wasn't it? That was not very nice, but oh well. Here we go. What does this tell me? Cosecant is positive, which means my sine value will be positive. My cosine is positive. Hallelujah! Which quadrant? Whew. Do I even need to worry about my sines? No, but I still need my first quadrant because I've got to draw my angle T. I've got to drop the altitude, but I know that everything's going to be positive, so that's a good thing. Now, go over here. And guys, this is exactly how I do the problems. When I show you this, this is what I do on my own paper when I'm trying to do the key for you. Oh, well, that's not what I do. Here we go. Tangent, cotangent. What am I given? I'm given that the cosecant is 5 or 5 over 1, which makes my sine what? 1 over 5. Okay? I go to my triangle. If the sine is 1 over 5, that means my opposite is 1. The hypotenuse is 5. Oh, my Lord, how do I find this third side? Pythagorean equation. Here we go. Shortened version. My hypotenuse is 5. The leg is 1. And I get 25 equals 1. I get 24 equals L squared. I take the square root of both sides and I get 4 times 6. 2 root 6. How many of you got your third side to be 2 root 6? That's what you should have. Okay, it's got to be simplified. So 2 root 6. Now I have enough information, wow, that I can fill in the rest of my trig functions. So the cosine of t, some old horse caught a horse, 2 root 6 over 5. Do you guys agree with that? Holy, getting ready to rationalize. Flip that thing over. Look what you get. What do I use to rationalize this? Root 6 over root 6. That gives you 5 root 6 over 2 times plain old 6, which is 5 root 6 over 12. Do you guys agree with that? Okay. Ugly but doable. Tangent, some old horse caught a horse, taking oats away. 1 over 2 root 6. Do you guys agree? Rationalize it. By multiplying by the square root of 6 over square root of 6, which is root 6 over 2 times 6, which is square root of 6 over 12. Yes? Can I reduce? Why? Because it's under the house. One's in the house, one's out of the house. They don't talk to each other. They're kind of hateful. Now, Damien asked me a good question. When I get ready to flip this thing over, which one do I want to use? Can I use the square root of 6 over 12 and flip that over? But when I do, what's going to happen? I've got to rationalize. What's the better term, the better number to flip? The very first one. 1 over 2 root 6, because when I flip it over, what does it become? 2 root 6. If I flip, did anybody take square root of 6 over 12 and flip it and rationalize? Did you get the same thing? Yes, you get the same thing. It takes you a little extra work, but you still get the same thing. Am I done? Let's go back and check our answers. Which quadrant are we in? Quadrant 1, where this is the land of what? Positives. Hallelujah. How many of you got this one right? Hands up. Very. No. because we're in the first quadrant, and everything is positive in the first quadrant.
Okay, so in all the rest of them, like say it's negative, positive, you want it to be negative.
Negative, positive be in the second quadrant.
Yeah.
All star, so sign will be positive, and its inverse will be positive. That's the only two that are positive. Everything else in that quadrant will be negative. That goes back to that chart yesterday, all-star trig class. If you learn that, those letters represent the functions and their inverses that are positive in those respective quadrants. Okay, so you've got everything's positive here. Sine and cosecant are positive in the second quadrant. In the third quadrant, all-star trig would be tangent and cotangent are positive. All-star trig class. Fourth quadrant is cosine and secant are the only two positive in the fourth quadrant. Okay? Go back and you got to think that all-star trig class all the time. Now, what if I were to extend this problem and ask you this? Because you will be asked this. So call this example 3b. Okay? Find this. Cosine t plus sine t. This is just an extension of the third example. Find cosine t plus sine t. What will I do? Well, what was sine? It was 1/5. What was cosine? 2 root 6 over 5. Can you add those together? Oh, you just smush them together. That's really high tech, but it's correct. You do just smush them together. Why do you smush them together? Because they have the same denominator. So I'm going to rewrite this as 2 root 6 plus 1 over 5. Really? What does that mean to me? Nothing but, bless you. But it does mean that we're doing what? Bless you. That we are blessing you and paying attention to what the question is exactly asking. Okay? You will see this again. You know that, right? If I show it in the notes, you know you're going to see it again. Cool? Because this is like having 2x plus 1, and they're not like terms. I think of the radical as a variable. Okay? Good question. All right, so one more step. You know that piece of paper that I gave you with the 3 unit circles, right? All right, give me a second. Let me... We're working to the bell, folks, so just deal. Here we go. Last example, folks. This is your unit circle in terms of real numbers. You can, I don't care which paper you write on. I would use this. Because, and you'll see why. That's why I gave it to you. I would use this and maybe make the first circle your example. You're going to use the last 2 for your homework, okay? This is the unit circle in terms of real numbers. And you need to realize that this is in increments of 1/10, okay? We talked about this yesterday. Why? I think we talked about it in here. Because pi is equivalent to 3.14. And if you look, yeah, see how it is about 3.14. You make one complete revolution and it's almost 6.3, 6.28. Now, here's what you're going to do. If I were to ask you, these real numbers are based upon radian measure. So in your calculators, because we're going to show this using the triangle, but we're going to verify this with our calculator. When you check this, verify it with your calculator, you're going to have to put your calculator in radian mode, which is something foreign to us. We don't typically do that. Now, this is all you have to do. We have to find the tangent of the angle 0.8. Okay? Check this out. We count 8 tick marks. Why? Because we are looking at this unit circle in terms of 1/10. Okay, so watch. Start counting. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10. No. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it is right there. Okay, you can do that. I like to count. That's why I teach math. So when I put my point, my terminal point on 0.8, then what do I have to do? We've done it all class today. I have to draw my angle first, and then I have to drop the altitude. Right? No. Put your right angle in there. Okay, your angle is here, close to the origin. We'll call it T. We know that it's 0.8, just like always. But folks, what is the hypotenuse? Why is it 1? Because it's the radius of the unit circle, and the radius of the unit circle is always what value? 1. So it's 1. Is there another value on there that we could actually count and figure out? Why is it the adjacent? Because I got the little tick marks there on the x-axis, don't I? All right, so let's count across. 1, 2, 3, 4, 5, 6, 7. Do you guys have about 7? Is it going to be straight up 7 or something different? Why is it 0.7? Because it's in terms of tenths. Very good. Don't let me fool you. Why? No, we did not. We went around 0.8. Could I? I could. Would it be very accurate, though? Oh, why are we going to do that, Quentin? Don't be pouting. I saw that. We have to find the third side, just like always. What's your question, Christian? The adjacent side, count the tick marks. Count 1, 2, 3, 4, 5, 6, 7. And remember, the tick marks represent tenths. Okay? Damien? I don't. It's 0.7. It's supposed to be 0.7. Okay? It's 0.7. It's not negative. Can a distance be negative? No. Okay, here we go. Hypotenuse squared. Hold up. Now, see, I'm a tree person. What 2 sides do I have to have? Because, y'all, I'm not finding all 6. I'm only finding what? I'm only finding tangent, which is taking oats away. I've got to have that opposite side, so I have to use the Pythagorean equation. Here we go. I know. It just puts hair on your chest. Hypotenuse squared is 1. Legs squared is point. Ladies, not for us. Not for us. It removes permanently the hair from our legs. Yes. Here we go. God, wouldn't that be great? TMI, gentlemen. Sorry. 1 squared is 1. What's 0.7 squared? Point calculator. Figured out. Is it 0.49? Okay. 0.49. Subtract 0.49 from 1, and you should get 0.51. Take the square root of it. Now, let me tell you something. Do not round. Do not round this. It's a long number. May I use your calculator? Thank you. You will understand why in just a second. Point 714142842 Holy moly. Don't write the whole thing. Suck it up. Do it. Point. And it's all in your calculator. Y'all like, what is it? What is it? Get your calculator out. Here we go. 0.71. 41428,429. Holy moly. Taking oats away. Oats away. What's my opposite? Oh, yeah, I'm going to write that number again. Here we go. 0.7141428429. What's my adjacent side? 0.7, really? What is 0.714128,429 divided by 0.7? Look at you calculating with your non-calculators. Shouldn't be 10. Check and make sure you got your decimal in the right place. May I? Am I going to write the whole number down? Yes, and I'm going to tell you why. You are fussing and whining about writing a number down. 1.020020, right? Dot, dot, dot. Just write what I write. Okay? I'm trying, because I don't want y'all to cry. Use up all my tissues. What's that mean? That using the triangle, that the tangent of the angle 0.8 radians, the tangent value is 1.02020 blah, 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 blah. Put your calculator in radian mode. Because this is what you're going to have to do for homework. Go to mode, which is beside your yellow second button. Arrow down to degree radians and put it in radians. It probably is. If it's not in radian mode, put it in radian mode. And now go back to the home screen, folks, and figure out what your calculator tells you the value for tangent of 0.8 is approximately. Because we don't do things the easy way, Morgan. No, 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 no. How much? 1.029, but hold up. Dot, 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 right? Where are we close? All right, now here's what I want you to, I'm going to suggest this to you. How do we know that we were spot on with the length of the adjacent side? We don't. We approximated. We said, yep, let me see. Yep, it looks like it's 0.7. We approximated. We said, yeah, that's what it looks like. But we didn't know for sure. But folks, if you check this or verify in your calculator that you have 1.02, are we not close enough? I mean, seriously, we're off by 1 cent. $1.02 and $1.03, right? Sometimes. Do you understand what I'm saying? You have the ability with your calculator to go back and verify in your calculator to make sure that's where you need to be, okay? We need to be in the right ballpark. We need to be in the same ballpark, okay? We don't need to be at the same complex, different fields. We need to be on the same field, okay? Now, here's what you're going to do for me. I'm going to just tell you right now, 35 through 37. Don't you roll up in here tomorrow and go, I didn't understand. I better see you in the morning because that's your tick mark unit circle, okay? And then 61 through 68, that's like the first part of your notes. You can.